Hello, everyone, and good morning. Welcome back once again to the Pineland Speaker Series. Today, we have a really interesting program on the recently changed spongy moth caterpillar. We're discuss a little bit through the program the name change. We're very fortunate today to have two longtime veterans of two of New Jersey's probably most helpful organizations. We have Steve Rettke from the Rutgers Cooperative Extension, and we have Joseph Zoltowski from the Department of Agriculture. Over the years, the Cooperative Extension and the Department of Agriculture are two great resources for homeowners, for farmers, and we really appreciate their time to help educate us today about the spongy moth caterpillar and some of the ways that we can protect against it and some of the ways that we can work with it. And on that note, I'm going to turn the program over to Steve, and I'll talk to you folks later.
Okay, well, good. Thank you, Joel, and good morning, everybody, and welcome to this talk on the recently renamed spongy moth. I'm teaming up with, as Joel mentioned, with Joe from the New Jersey Department of Agriculture, and so we're going to make this kind of a tag team type of a presentation. It's going to be extemporaneous, and we're just going to go along and see how things work out. But probably most of you who are listening have not heard yet about this name change. And it's now being by the Entomological Society of America made the change to spongy moth. And the reason for that was because of the maybe the somewhat negative connotations with the term gypsy. It was a term that has a derisive history to it, where some of the Romani ethnic groups out of northern India began to migrating into Europe, and they were rather an insulated group, and some of the white Europeans begin to call them gypsies, and it's not a name that they called themselves. So the name was made change, and okay, now I just have to wait for I had to change the slide. There we go. And the reason it was changed to spongy is because what the egg masses look like, and it does have somewhat of a spongy appearance to it. And I'll talk more about egg masses as we go through this, but that's the reason for the name change, because almost 10 months out of the year, it's in this particular life cycle, even though there is only one generation to the spongy moth. By the way, if I say gypsy moth by mistake, please forgive me. And so therefore, yeah, they decided this was maybe has a rationality to it as far as naming it to the spongy moth based on the appearance of the eggs. All right, so this is a photograph that was taken by the New Jersey Department of Agriculture. If you look at the upper left, there's the date that states April 2007, and has rather an eye-catching title to it, Voracious Tree-Killing Gypsy Moths. This obviously trying to get attention. But back in that time, around 07, 08, 09, there was a resurgence of this particular caterpillar pest in New Jersey. And so I have a question there that I'll answer maybe a few slides from now, but do spongy moths directly kill oak trees? And there are other trees they feed on. In fact, their host is quite wide. Probably 300 have been known to feed on plants and trees and shrubs. But do they directly kill the oak trees, which is the focus of most of the control is on that particular species of tree? And I'll answer that question a little bit later on. So yeah, kind of by the way I worded it, you probably have an idea that the answer is oftentimes no. And so this is just a brief history of it. It all kind of accidentally got started in Medford, Massachusetts in 1869 is the year I've read. And it was being kind of a research being done with trying to hybridize the native silk moths with this imported gypsy moth that was intentionally brought over, but it escaped from the lab of this particular researcher. Medford is about just north of Boston, by the way, kind of the northeastern section of Massachusetts. And it was released, and but they kind of lost it. But 20 years later, it became an outbreak, as indicated in 1889. Here on the streets of Medford, there we go. We got an infestation and the first outbreak of the spongy moth in this country. And in New Jersey, it first began spreading pretty consistently around the mid to late 1960s, although apparently it actually was first introduced around 1920 by an import from Europe on a Christmas trees, I believe I remember reading, but they were able to kind of suppress that. And so it was in the 60s that it really started going. And then in New Jersey, the peak defoliations occurred around the early 1980s. Okay. And then for the last 100 years, the average spread westward of this pest has been, over a dozen miles per year as it continues to move west. And they're doing a lot to try to, stop the spread at that leading edge and the more of the western states.
USDA,
Yeah, go ahead,
right,
Joe.
so the USDA has, they have a slow to spread project, like you said, about 13 states. Pretty much it goes from like, I want to say Wisconsin, just kind of draw an arc over around the Northeast US, and it kind of goes down to North Carolina. So that Northeastern region, the USDA has a good gypsy moth quarantine against moving any life stage of gypsy moth out of those areas. So you get homeowners moving out west. And we're in touch with moving companies, to inspect for eggs, inspect for any kind of larvae, kill them, remove them before they load them into the trucks and move out west. And they still get moved out there. But the USDA has two programs. They have a slow to spread program on that leading edge from Wisconsin down to North Carolina, where they put traps up, they do mating disruptions to mate the biological. You'll see later on the biological pheromones, do pheromone traps, they do pheromone flakes to disrupt the mating activities, to reduce the populations. And then they do follow-up aerial spray operations behind that leading edge to reduce the populations even further. They haven't stopped it, but they have slowed it substantially. So it's a slow to spread project now.
So I don't know if that 12 miles per year it's not a consistent thing, and it probably has starts and stops and periodically as the decades have gone by. But there actually is a map that I'll get to. I think maybe I'll go to that now. Not quite yet, but this showing you here why this pest is quite the problem at times. It has the caterpillar stage after it hatches, usually in April or early May, depending upon where you are in the state. They have 5 or 6 instar larval stages. Apparently, the males have 5 instars, the females have 6. And during those last couple instars or so, they are able to eat up to about a square foot of oak foliage in 24 hours. And they feed continuously over the 24 hours, over, I don't know, maybe a week or so, in the final stages before they pupate. And so this creates quite an amount of defoliation, and oak trees that are significantly, and other trees as well, because they do have, as I mentioned, such a wide host range. But the oak trees are the focus, and they do significantly stress the trees after 2 or 3 consecutive years of 50% or more defoliation. So that's often the key, at least in the more forested areas, is to avoid having the oak trees being defoliated by more than 50%, because that, especially after 2 or especially 3 consecutive years, it really stresses them and puts them into problems where they begin to attract other pathogens or insect pests like wood borers. And I have something coming up on that really quick. And this is a nice photograph taken 2007 by the Pennsylvania Department of Agriculture. And it's in the central Pennsylvania, Allegheny Mountain Ridge areas. I think this is just north of State College, Penn State area. And you can see the defoliation at the top of the ridges that has taken place. And so notice also in some of the areas, this was taken apparently in July, you already begin to have some refoliation starting to occur. So the trees are able to recover, but there's a limit to, that takes a lot of reserved carbohydrates they store in their roots. And this happens consecutively after numerous years. It stresses them, and then they become more prone to other problems. And so unless you have anything to say about that, Joe. Otherwise, I can go right to some of Go ahead.
So pretty much after a couple of years of defoliation, because they're so stressed, they will refoliate. So the first year they're defoliated, they'll put another flush of leaves out, and the leaves are smaller, and you can tell that they're stressed out. But the tree is fighting to, store up enough nutrients to overwinter and refoliate the next year, right?
Right.
And then, so now the next gypsy moth is a bad insect in the fact that they will stay in that same area, lay eggs, they'll mate, they'll lay eggs, and they'll hatch again, stressing those trees further. And after a couple of years, you'll get tree mortality. Those trees will give up the ghost. And then I've even seen it sometimes, some years when they're very bad, when you had complete defoliation, like that photograph we just saw in Pennsylvania, in areas like that back in 2000, I want to say 2000. We had a drought coupled with that, and those trees gave up the ghost after just one complete defoliation because they were just so stressed out. So there was a lot of timber left over. So climatic factors have some additional stresses that go on those trees as well, besides the defoliation.
Another kind of a problem with this defoliation, and if it does start to kill large acres of forested land, guess what is one of the invasive tree species that typically moves in? It's the one that we've been hearing about, the tree of heaven. They do not grow well in any kind of a dense shade, but when you have an open area, they can really take off and begin to dominate and be the primary tree species. Then this is the problem now with the spotted lanternfly. So there's other problems with defoliation of things like oak trees as well.
And then other things too, you have increased fire load going on. So if a fire, God forbid, started in those, if all those trees that are brown on the slide were dead, by mortality, you get a fire in there, that fire gets hotter and it burns hotter and it spreads faster depending on the weather. But that increased fire load compared to what a normal canopy covered forest has, a lot of moisture in it. Takes a lot to get a hot fire going on there, even though it happens. And with that dead timber, you have an increased fire load, so the fires get hotter and more dangerous. That happens too,
All right, well, kind of answer that initial question I had, do gypsy moths directly kill the oak trees? Well, it's possible they can if the tree is severely stressed year after year, and especially if there's things like drought that are taking place. But there's another thing that can come in, and these are often referred to as the true assassins of trees, which are wood borers. In this case, it's the species known as the two-lined chestnut borer, which will be very attracted to any kind of a stressed oak tree. And they'll come in, and once they infest and build up over a couple of years, they typically take the tree out and kill it. And then there's another pathogen that's becoming a concern as well with stressed trees, and that's the armillaria root rot, which is, there's several or a multiple number of species that are, every state in the country or in other parts of the world also has this particular fungus. And it may not necessarily always directly kill the tree. It depends upon the species and its condition. But this is one that, just like the two-line chestnut borer, will be an additional stress that can take the trees out and kill them. So, all right. All right, and this is a map of showing you this is relatively, let's see if I have the date on here. Yeah, it's, well, it's not quite up to date, but it's November of 2020, showing you where some of the management zones are with this particular caterpillar. And it's USDA and APHIS quarantine, which is the dark blue, which is certainly almost the entire New England and Northeast section. And you can see the lighter blue color is where they're doing some monitoring. And that's kind of the leading westward edge. And this is what Joe was talking about. We have things like mating disruption pheromones that are being put out to try to, and I guess also a good amount of BT treatments as well, Joe?
Yes, absolutely, right. Yeah. So it would be both. And that the green color would be the slow the spread zone. That's what they do with the mating. First they would do the suppression, the BT sprays, for example, using aircraft and ground rigs and that kind of stuff. And then they do mating disruptions because when they're adults, they don't feed. And so all they're going to do is the females put off a pheromone, the males find the female, they mate, they lay eggs, and that's pretty much their life cycle. So a 2-week period of time, they try to use up the male's food reserve so they can't find a female.
Sure.
That's the intent of that. And it works relatively well. It has slowed it down, but it has not stopped it by any.
It's kind of a cruel trick we play on the males, isn't it?
Yeah,
They're
for
just
sure.
they're just blundering around there trying to find females, which are, because of the pheromone saturation, they're everywhere, and they
Right.
can't find her. And so there's not a lot of mating going on. So all right, and just showing you here. This is, I don't know if you can see it if I'm blocking, or photographs are blocking the area. I can probably move that if I can. I don't know how it looks on you. Maybe it's just my screen. It doesn't move it from your screen, but you can see the life cycle stages. And this is egg stage. And it's kind of a peculiar looking, unique shape to it because it's wrapped around a relatively small twig. Usually the female spongy moths will lay it on a fairly flat surface of the trunk or branches, and it'll have more of an oval shape to it. But this was wrapped around this small twig, and you can see, when the female lays her eggs, she uses the hairs on the undersides of her abdomen is what kind of covers up the eggs, and that's used for protection. And so that's what all that light brown coloration, almost yellow, and it changes color after the eggs hatch and the egg masses age. They change colors and become more of a whitish coloration. Yeah.
Right. So pretty much, I mean, as a generality, I always tell people that the females are they like shady spots, so they'll lay them on the shady sides of trees, underneath tree branches, those kind of places, underneath picnic tables, on the shady side of a post. But pretty much they'll lay eggs wherever they want, right? They can lay it on your lawnmower or a mobile home if you have it parked in your backyard and you have gypsy moth there. So they'll lay them anywhere. And like Steve was saying, this is a nice photo because you could see the eggs that aren't covered up with the hairs. And so they're dark. If you squeeze them between your fingernails, they'll pop, because they're fresh. They're going to hatch out. Once they hatch, that's it. The eggs they're not going to rehatch another year. They all hatch out at the same time. And the caterpillars go through different phases. They go through a migration phase, and then they hunker down and get into the feeding phase. But once all those eggs are hatched, the wind will rip up the egg masses, and you'll get this ratty kind of torn appearance to the egg mass, and the sun will bleach it out, so they kind of turn whiter. So when if you're looking on your property or somebody else's properties for these, the whitish ones in general are old egg masses. And I say in general because you can see egg masses that have been bleached out by the sun that are still viable, right? If the females happen to lay it on the sunny side of the tree for whatever reason. And so you can see white ones, but pretty much we always tell people, if you look at the egg masses that you're seeing on the trees, if you could find something that you can touch and it's spongy, then it's an old egg mass you don't have to worry about.
Yes.
So the new ones that have that buckskin color like you have here, those are the new ones. They're always new. When you touch them, those egg masses are firm. They're not spongy feel. So just a little heads up for if people wanted to scout on their own.
Joe, I'll have you later on talking about what the Department of Ag does with their, I don't know if you still do it yearly, but after leaf fall and the late fall and even into the winter, you do egg mass counts.
Right.
And it can be kind of challenging to get accurate counts, but I know you do it mostly from the ground, right?
All our egg mass surveys are from the ground, and we'll get into that later on.
Yeah, we'll talk about that later. Just to finish up with this slide, just the life cycles you can see there. These are just generalizations as far as the months, because it depends upon where you are in the state. If you're up north and say somewhere in Sussex County, or you're way down in maybe Cumberland County, there could be a difference in this life cycle by 3 weeks. It's remarkable, even though we're a pretty small state. The changes with the weather, because of course insects are cold-blooded creatures, and they're very dependent upon weather and temperature for their growth and development. And so I say mid-April, but that's probably South Jersey. As you go up further north into the northern counties, it's going to be early May. And then you can see April through June, you have larvae. You can even have larvae as late as into early July. And then the pupae, and I'm not going to continue with this, but the adults are going to be active mostly in July and maybe as late as into August. Right. And then the egg laying takes place in July and August as well. So you have eggs that overwinter from July all the way for many months until April, until when they start maybe hatching. The early ones begin to hatch. So,
Right.
All right. So I just wanted to show you here that most egg masses are an inch in size. I guess when they get really large, they can be up to maybe an inch and a half in length. But the number of eggs per egg mass is usually the average around 400 to 600. But I've been told they can get up above 1,000 during really severe outbreak years. And so you've got that July through April period to remove the egg masses. So. All right. And this is showing you, and it's going to be probably in July. We have the adult female spongy moth. I always have to pause. And she's laying her egg mass there on a I think it was a oak tree, and they don't fly. The females do not have the ability to fly. They perhaps, Joe, you can tell me, do they have the ability to glide? They can perhaps glide, but they can't actually fly.
I've never seen them glide off the top of my head.
No, I have not either. No.
Right. They mostly just kind of crawl around.
Yeah.
I do know, like, this is a nice, healthy female, when they get stressed out, when they overpopulate a place and they eat all the resources that are there, and they're kind of develop a little bit faster than the standard development time that they have allotted for them. You'll see females with not so fully formed wings. They have half wings. They're kind of deformed looking, but they're still laying eggs. They're still reproductive, and they're just kind of walking around. And even the ones with wings, I just see them walking around. The Asian species that we don't have, but are a pest out west or introduced out west, mostly they come from Asia. Hence the Asian. They don't really have a common name for them yet. We just call them AGM. How's that? And so the AGM species, the females do fly, and they lay bigger egg masses, and they're a little bit bigger than the European versions of what we're looking at here. And those, us in the USDA do survey for those, mostly in the port environments, because they come in through the ports. They're not native here. They haven't been established out west where they find them. They do eradications and do follow-up year after year follow-up surveys to make sure that they didn't miss any. So they do a good job out west eradicating when they do find them in a port environment. So I'm sorry.
That's good. No, I remember taking this photograph, and I think it was in 2007, and it was right near the Manasquan Reservoir area, which is where I used to live in Farmingdale, just a couple miles away. And I was scouting these areas where there was a lot of gypsy moths, and I remember in that same area there were a lot of these males, which are more of a drab gray color to them, and they can fly, and they kind of fly in a zigzag herky-jerky pattern. And to try to get these guys to settle down, and so I could take a photograph of them, it took a little persistence on my part. And so, but they have an elaborate antennae because they need that to detect the pheromones that the females are emitting. And so,
and the thing with the males also is that, so most moths are nocturnal. You would see them in the dusk. You'll see these males flying, trying to find that female during the height of the day. They're zipping around at noon in broad sunlight. They don't care, but you see them going through these areas trying to find that female.
Yeah, and so there's just another photograph, close up of this rather somewhat elaborate antennae that the males have, and that's true for a lot of these insects, that the adult males have to detect pheromones that the females are giving them off, the volatiles that are in the air that they have to be able to sense and detect. And so they use their antennae to do that. So, and this Joe was talking about this as well. So kind of a poor photograph. I don't think it was taken out of a book, but you got not a real accepted common name, but the Asian spongy moth on the left, considerably bigger than the more European spongy moth, the one we're dealing with. And those are both females, but as Joe mentioned, the female does not fly, but the European does not fly, but the Asian species or variety does. And so also, apparently the Asian variety feeds on more plants, hosts. European is maybe 300 host plants capable, and the Asian is 500. And as you they,
And the Asians even prefer pines and coniferous species
yeah,
more than the Europeans. The Europeans will eat them when there's nothing left to eat. By
yeah,
God, they're going to eat. So they will do that, and you'll see them defoliate things. But the Asians show no preference; they'll eat whatever's there, and it doesn't
right.
affect them developmentally.
So
Right?
we need to keep this particular variety out of the country the best we can, and work on them. And this showing an egg hatch of the spongy moths from. I don't know. This is indicating that it was beneath the egg mass, but what I meant by that is they're coming from not from the top of the egg mass, which might be confused. You maybe see those little exit holes in there. Those are probably from parasitoid wasps that emerged, but they only get near the surface. And then the gypsy moth first instar, as showing here, initially when they first emerged, they had kind of a whitish coloration as the exoskeleton needs to harden off and then become very dark in color, and they're quite tiny, this first instar. And so that's just an early hatching taking place. And I showed this interesting thing that I happened to pick up. I do a lot of greenhouse monitoring during the spring period, and this was at a greenhouse where it was a heated greenhouse, but it was a hot day in April, and so they opened it up, and the first instars with gypsy moths, bagworms, by the way, caterpillars do the same thing. They have a ballooning period, and it's how they can spread. And typically, when those first instars are hatched, a good percentage of them will move higher up on the plant if they're not always up there, and then they'll weave some silk out of their mouth, and they'll just simply take a leap of faith, and they'll just let the wind blow them where it can. And if it's a sufficiently high elevation where they're being released from, they can blow, hundreds and hundreds of yards, is not further. In fact, that photograph with the Allegheny Mountain ridges, they could potentially blow for miles downwind. And so you could have an infestation from an area that you had no egg masses, and suddenly you get these blow-ins coming in, and you got a problem. So
yes, that's right. Yeah.
And this showing you as they're developing through their instar stages, they become more what we're familiar with as far as what the larvae look like. I don't know for sure what stage of instar this is. It's at least a fourth instar, and it may well be a fifth instar. But you begin to see that the first 5 pair of spots there near the head are blue, and then the 6 back spot pairs are kind of a reddish coloration.
Right. Yeah. And going back, Stephen, to what you were saying, so when the eggs first hatch, they're not really, their behavior is more dispersal. So the first instars, like you said, crawl up to the tops of the trees or plants or wherever they're hatching from. And they go into dispersal mode, and then they land wherever the winds take them. And once they hunker down and start feeding and get to this size that you're looking at, the later instars, now they're just voracious feeders. Now they're going to eat and eat and eat until they go into pubation, which is their next phase.
And my understanding also is the earlier instars will primarily feed at night, and then during the day they'll climb down. And I assume the behavior for this is to avoid predation during the day, and just I have a photograph of what has been used as more of a cultural physical control using burlap bands around trees, and we'll talk about that when we get to those slides. So, and this showing you a full size. This is probably for sure 5th or 6th instar. Didn't take this photograph myself, but we're talking usually June or even July, and that's just a close-up of a mature late instar gypsy moth or spongy moth. Okay, and just showing you here the pupal cases. Once they do pupate, they finish up that 5th or 6th instar, and then I assume that most of the pupal cases were going to be down on the ground, and I'm sure some could be on the trees themselves. But
I've seen them up, like they'll spin a bunch of them will cluster together underneath branches, and they'll spin like a silk webbing, and you'll see not like 1 or 2, there'll be multiples, especially when you have high populations.
I've seen that.
They're usually underneath branches, and they'll just kind of hang there until they finish pupation. A few weeks and they come out.
As you can see, this is typical in the insect world where the females are going to be larger than the males, and that's just the normal trend that we find in a lot of different species of insects. And just showing you here as far as hosts and what they feed on, I took this photograph. This particular red oak is our New Jersey state tree, and it has bacterial leaf scorch, which is going to be another stressor if it happens to have an infestation of spongy moth. But this is one of the preferred hosts. So they like, it's even been my understanding they may even prefer the white oak group even more so than the red oak group. I don't know if there's much of a difference between the two, but this is what I've heard.
They like it both.
Yeah.
As a generality, if you have a chestnut oak, which is in the white oak group, you have a chestnut oak, you'll find more on those than you'll find the next fewer amount on white oaks. And then I think because of the bark, they like that rugged bark the females do to lay their eggs on. So the white oaks have like a flaky bark they could kind of hide their egg masses on.
Yeah,
right?
that's right.
Same with the chestnut oak, they're all ridged and they like those ridges. I've even seen them do a similar thing on sweet gum because that has kind of a ridge bark. You know what I mean? Even though they don't really, they will feed on sweet gum, they don't really defoliate it, but they will like to lay eggs on it because of that bark.
Yeah, I have a photograph further down where it's showing egg mass that was this exfoliating bark is, which is more commonly found on the white oak group.
Yeah.
And so this is showing you, our photographs may be blocking some of these, the text on this, but the one on the left is some of the preferred hosts. Can you see that, Joe? Or
no, it looks good.
When I move this, do you see it moving on my screen, or probably not?
No.
No, I didn't think so. So I'm going to just keep it over here on the far upper right. But they're showing you some of the preferred oak hosts, and it's just only some of them. I mean, those are probably some of the top ones that they go after. And then on the left is, or rather on the right, is some of the more rarely fed upon hosts. And it's things like tulip trees and I think black. I don't have this one listed there, but I think black walnut is one of those that has a alleliopathic type chemicals that are apparently not very tasteful to the gypsy moth. But some of these trees that are not necessarily favored, as Joe mentioned earlier, when they get outbreak populations or later in their instar periods, they can and will feed on some of these other trees as well. Yeah,
I've seen it in worst case scenarios where all the foliage were off the trees. This is in Burlington County. I don't know, maybe 8 years ago. They stripped the place clean.
Wow.
And all that was left was grass on the lawns. And they were actually, the homeowners were complaining about gypsy moth. And yes, they had not a leaf on the tree.
Yeah.
But the caterpillars were lined up eating anything that was green, and they were actually destroying the lawn at the same time. So once they start feeding, they're voracious. They're like sharks. They just keep eating.
Yeah, I know. I monitor Christmas tree farms as well as part of my responsibilities at Rettke's. And I have one old-time grower who's considerably older than I am. And back in the early 80s, he said his Christmas tree farm, 55 acres, was almost useless one of those early 80 years because he didn't anticipate there being a problem with the spongy moths feeding. And it really pretty much wiped him out that particular year. And once a conifer gets defoliated, by the way, it often will kill it because conifers store a lot of their reserved carbohydrates in older leaves, whereas the deciduous trees have a better chance of recovering because they have stored energy in their roots, whereas the conifers do not. So, all right. And this is showing you some of the defensive chemicals. I don't want to linger on this, but for the most part, usually a lot of insects are restricted as far as what they're able to feed on based upon what hosts have certain defensive chemicals in them. For example, alkaloids are not usually preferred. Things like nicotine and morphine are less preferred by the spongy moths, even though they will, if they eat to, feed on these trees. And that's why trees like the the tulip tree and maybe the black walnut, they contain these alkaloid toxins that they just don't really like to feed on. And there's one there, the second one, the phenolic compounds containing tannins. That's one of the primary defensive toxins for oak trees. Well, apparently it doesn't slow down the gypsy moths or the spongy moths at all, because they apparently have, I don't know, enzymes perhaps that are able to break down the tannins very rapidly, and they can continue to be digest the leaves well without any problems.
Right.
So anyway, and a lot of the conifers contain terpenes like pine resins and taxol and so forth. But anyway, that's just showing you. I just want to mention the fact that trees do attempt to defend themselves. It's just that it's unlikely that this particular slide states here, the spongy moths are an exception. They can really feed on a lot of different hosts with different varieties of defensive chemicals. And so
a lot of that, I think, gets into the invasive characteristics of not being so. Hence the invasive, even though gypsy moth, like Steve was saying, it's been here for about 100 years, from Massachusetts to where it is now. But it's the classic invasive species, and so they had no predators. They had lots of food, and because they'll eat almost anything, and they're very hardy, where they're more resistant to native diseases that would be in the United States environment, for example, compared to Europe. But they can withstand those. There was nothing really preying on them until people do something, and the trees do their best. But because they're very hardy, they can, I guess, their digestive systems or their enzymes in their bodies can, can bypass a lot of stuff.
Right. So, Joe, I think maybe this is time you perhaps want to take over for a while. And this is some of the research and sources from the New Jersey Department of Ag.
So this goes back.
Joe, tell me when to advance.
Okay. So you can see the history of gypsy moth. They used to have these nice cyclical patterns, right? That you can see the major outbreaks, obviously, in 1982, 79s to 80s, we had almost 800,000 acres defoliated throughout the whole state. And it was gigantic. That was the most we've ever had. And it kind of petered out, but it had you can kind of predict if the cycles were going up or down, right? Because every population has a peak and they start to decline, even humans. We all do that. Any kind of population does that, even insects. So you have good years, bad years. And down the bottom, you can hardly see that, but we have some dark, response graphs. That's where we were doing treatments, very dark blue, I guess, on this slide that I'm looking at here. And you can see that kind of going through. And there's a fungus that has been released that you can take notice. And when I was talking about the drought, with gypsy moth was killing after 1 year defoliation, and we had the drought, and that you could see that spike in 2000, where that coupled with complete defoliation over 100,000 acres, and we had a lot of tree mortality. Most of that was in the northern counties of the state, and they started coming back again. And there's a fungus, I think, that Steve will probably get into in the future here, that in 1989, when we had that big explosion, if you go back on that chart before 91, we had that big spike. Well, most populations would slowly decline, like you see in that chart from 79. They have a slow decrease there. 1989, we found this fungus that pretty much collapsed the population or wiped them out. And all this was happening up in the mountainous parts of the state. Mountainsides were stripped clean. And we expected to see a lot of egg masses all over. They're going to hatch again, doing the same kind of defoliation. And there were places that we couldn't find egg masses at all, none. And so something killed the caterpillars. What was it? And it was, lo and behold, was this, they call it the Japanese fungus, but it was Entomophycum mymega. It was introduced by the U.S. Forest Service up in Massachusetts, decades before, as a biocontrol, as a natural biocontrol. And nothing was ever seen. No one ever reported any of this until we found it in our state in 89. And then other northeastern states started reporting the same kind of thing, these population collapses because of this fungus without any spray activities going on. So because of that, we don't have a nice predictable curve anymore to go, or the population's going up or going down, because that fungus becomes active when during the caterpillar phase. If the environment is extremely wet, meaning it's very wet, they can cause local and sometimes regional population collapses of gypsy moth without anything being done, right? So hence we have these, little sporadic outbreaks that you see in 2006 and 15, and recently we just had another one that just went on this year. So back in, I think the last spray operation we did was 2018. We weren't spraying a lot of acreage, but we had, I don't know, maybe 9,000 acres or so defoliated, and this it's not on this chart. So, but then pretty much gypsy moth populations were relatively low. They were in the deep woods, and it was like 1,000 acres hither and yon, and so we had about 1,000 acres here and there. And then, like I said, 2021, we had a little explosion of 10,000 acres defoliation in the Pinelands, right? Burlington County, Cape May County, not really as much in Atlantic County, but for some reason we had this explosion there, and hence we have some spray operations that are proposed for us to conduct this coming May down in Burlington and Cape May County, if that makes any sense. But you can see those acres that we have here, and you can kind of see the slow decrease, a big increase, and then kind of slow decreases almost down to 5,000 acres, and it slowly increases again. And it was like maybe a 5 or 6 year trend. You could start to use a population predictor until 1989. Now all bets are off. It's pretty much, we have to do it. And we do annual surveys. When gypsy moth defoliation is at its peak, we fly the state. We map where gypsy moth defoliation is. We contact those town administrators to line up fall egg mare surveys that we conduct to identify what areas we are going to, based on egg mass counts. They have to have egg mass counts, based on areas that we would expect to have severe defoliation going on the following spring. And we work with the municipalities to set up a treatment program the following year, if that makes sense. So you can go next.
Yeah, just made a comment that after 2009, from 10 all the way through to 21, with the exception of the year 2015, for those dozen years, the number of acres defoliated have really been quite low.
Right. So, I mean, we've always had defoliation, but it was like 1,000 acres here, 1,000 acres there. And we're talking statewide, which is nothing in the grand scheme.
What do you suspect? Was it weather related with the 15 increase?
So we had a lot of wet springs, and that's, like I said, that's very good for EMI mega to take effect on populations, especially in deep woods, right? So we do treatments in residential areas where there's large population, and some people spray woodlots as well. But in deep woods where nothing's going on, back in the day, I want to say in the 70s when gypsy moth was in its peak, in the 70s, early 80s. The Department of Ag, we have a beneficial insect rearing laboratory. And there was a lot of federal money that was spent for the department and other departments too, as well, to rear and release gypsy moth parasites. And so over the course of back then, we would rear and release egg parasites that, Steve, you were talking about. You had some holes in some of those egg masses there that is a species that's an egg parasite. And these little wasps would kill off. They wouldn't kill them all off, but they would reduce the population that's going to come back and start eating, right? So we would release them. We would rear them. We would release them in places where gypsy moth was bad. And pretty much, and we do the same, but there were larval parasites that were released. There were flies, species that would go after the larva forms. Nothing was really going after pupa. But we were combining that with treatments. We kind of knocked those populations down, and that's pretty much where we're at now. Eradication is way after the fact, and so now we're just in a suppression phase.
Yeah, I know last year, Joe, that you had about 10,000 acres defoliated, and they were predominantly in. You see my cursor here in probably the western edge of Gloucester County. and the northern edge.
So we had some over there, but it was mostly,
Yeah.
I want to say it's mostly over, like, so you see Burlington County where it gets pointy, right towards the coast.
Arlington here, yeah.
Yeah, so pretty much like towards the coastal, and if you just roll down to Cape May, it's kind of a straight line.
Oh, okay, all
The
through here
northern
then.
Cape May, that's kind of
Yeah.
our areas that we're at. We surveyed in Atlantic and didn't find a whole lot of it.
Yeah, a lot of the, the Pinelands area, or at least the
Yeah.
more southern areas, yeah. So,
Correct.
and so I know you put a series of maps that kind of indicate these areas that had the infestation.
Right, so these are focused in Burlington County. So these are our 22 proposed suppression programs. And pretty much we had seven municipalities, 3 in Cape May and 4 in Burlington County. And you can see, so here's a map of our proposal for 22, and all these towns have said that they're going to participate because they know how bad these populations are going to get. And a lot of these trees were defoliated before, so we're trying to save the trees, right? And so you'll see that here we have a recommendation of 2 applications, and how do we get there? So Suppression moth, they lay eggs, yes, and it's the number of eggs that are going to hatch that's going to be a predictor of next year how bad are they going to be, and what kind of damage are they going to do. And so when we do our egg mass surveys, we do egg mass counts, and I think later on we have some maps of what a 40th of an acre plot is, but we do 40th of an acre plots where you find a tree and you count all the egg masses that are in all the trees within an 18.5 foot to 20 foot circle. And you tally those up, and that determines what that population is theoretically going to be per acre. And so any places where we have anywhere from 4,000 to 6,000 caterpillars or more, egg masses or more an acre, which is a lot, that's going to we recommend to do a double application, because we do aerial spraying on our program. And on the aerial spray program, we use Bacillus thuringiensis, which is an environmentally safe pesticide to use. It's not a contact poison. The caterpillars have to ingest this material for it to affect them. And they have to be small. So now when we have to time it right where the timing is critical here. It's all early spring treatments that go on. So pretty much from the month of May to beginning of June is when all this goes down. And so we're at the mercy of the weather. Okay, everybody knows that. And we don't want to spray them when they first hatch because they're in that dispersal phase. So we have to wait until they disperse out from their places. So hence this blue line along those roads is where the populations are really heavy. And we focus on residential areas. That's why you'll see our spray blocks mostly focused on roads as opposed to deep woods. But so we know that there's populations going to hatch out. We're going to have a huge place there. We increase that buffer zone. So usually this is about roughly 800 feet wide, right on each side of the road for this particular case, because we have so many out there, so many caterpillars are going to be in that area, that when you use BT, you reduce the population, in reality, about 65%. So by doing a double app, but BT only is active for a week. Sunlight degrades it, right? So when we put that material out, we want to focus on weak young caterpillars so that it doesn't take a lot of a lethal dose to affect them. They basically stop feeding and they starve to death. That's how it works. And so we're essentially making BT, which is non-residual, because a week later, we'll put it out there, we'll kill what we can kill. And then a week later, we put the same material back out there to put another dose out there for whatever remaining caterpillars are out there to feed on, and then reduce them even further. That's a double application. So this is Tabernacle, and Steve, you can go to the next one, I guess.
Oh,
We'll just roll through them.
Yeah, you have you have like a half dozen different maps.
Right, so this is Woodland, same thing, and over here, you'll see a double app like I was kind of describing, but then you'll see other blocks that aren't as wide, and that's a 400-foot buffer, right? Because the populations aren't as high as the populations that are in the double app zone. So this is Woodland Township for 22. You can go to the next one. Bass River, so Bass River has a lot going down that eastern Burlington County thing. You can see they have both single and double applications that we're proposing based on those counts that we do. You can go to the next one. Washington Township has a lot. This is like, there's some heavy pine in there. You can see them scattered. They have a lot of double applications. They have huge populations. They have at least 4,000 to 6,000 egg masters or more in those double application areas. So there's a lot. So like I said earlier, we're going to do a single application out, come back 7 days later, do it again to knock down that population even twice. Now BT does affect larger caterpillars, but because the larger caterpillars, the 4th and 5th instars, and even 3rds for that matter, they're so healthy from eating that they would pretty much have to defoliate the whole tree to get a lethal dose of the BT. And that kind of defeats the purpose because they're stripping the tree. Now the tree's stressed. And so our job is to, save the trees. So we're trying to reduce the stress on the trees by reducing that population. That's the game plan of the program. So there's Washington. So now we're in Cape May County. We have Dennis Township. This is the middle of the road. We have Upper Township coming left too, but same thing. They have a lot. We have double apps in 2 of their blocks because of the population size. They're just huge down there. And they just popped out of the blue. Year before, in the same neck of the woods, we had maybe 1,000 acres defoliated throughout the whole state. And now 10,000 acres just in 2 counties. And they kind of hop, skipped, and jumped. Some of this might be related to, and I don't know, there's no smoking gun pointing to it, but they are associated or in proximity, not associated with, but in proximity to, frequent areas that are frequently, they have campsites, right? So we're thinking there could have been some firewood movement with egg masses on it that just hatched out and the insects dispersed and kind of started defoliating and took over. It's just a guess. We have no smoking gun for that. This is Dennis. This is Cape May County. You go to the next one. Middle Township. We have a lot in Middle Townships. You can see the spread of that. You can see the one campground is kind of eaten alive over in that 238, I think, acres. I can't really see the thing. But most of them are single applications in this township, except for that northernmost, which is right next to that previous township we just saw, Dennis Township. So Dennis Township had double laps. They're kind of spilling over into the northern part of Middle Township. And then last but not least, I think, you can go to the next one, would be Upper Township. And that's above Dennis Township. They have just one area that has a double application, but everything else is single up there. And you can see they're kind of spread. And there's a lot of fish and wildlife land that are out there. So there's a lot of deep woods where no treatments are conducted. And that's usually where they harbor and spill out into residential areas. So it's what we've seen, ad nauseum over decades. So there's my blocks for 2022. And we're working on that. We started treatments in May, and hopefully by early June, we should be done with single and double applications. Then what we do is we sit there, do an evaluation of what we did in all the blocks. Every block you see, we have over 30 something blocks to treat. We evaluate, was it good control, bad control, whatever. We do an evaluation to see why was it bad. If it was bad, was it weather induced? Did it rain in the afternoon? Even the material, once we put it out there, it dries within an hour. Once it's dry, it's tenacious. I mean, that material stays there, but like I told you earlier, the sunlight degrades it. So after a week, it starts getting degraded. You know what I mean? And so after a week, you can still see spots on the leaves, but they're not active anymore. The caterpillars can just eat right through that. It's like little pieces of protein they just eat. And that's what it is. But BT is a safe product, doesn't affect humans, wildlife. It's the same material organic farmers use for organic farming. So it's a good pesticide to use for environmental reasons. So that's what I have, I think, with these. I think that's it for the blocks.
Okay. Yeah, I'll tell you, I know that Department of Ag is also now really putting a lot of effort with the spotted lanternfly. And so you really don't need this spongy moth to resurge again. You guys are busy enough, aren't you?
Yeah, that's correct. Right. It's now I have multiple plates to spin. Yes, for sure. And both populations are increasing exponentially, we'll say, not astronomically. So
yeah, I know we've already kind of talked about the use of the binoculars to do these egg mass counts. I guess it's primarily in the very late part of the fall, and then you do it in the winter as well, don't you?
Yeah, we pretty much start our egg mass counts. We wait till all the eggs are laid by the females and all the adults are dead. So we get accurate counts. We get the total final count. If you do the egg mass counts too early and the females are still alive, they could lay some more eggs and now your count's off. And so we wait till September, and pretty much everything throughout the whole state, north or south, all the adults are dead. And that's when we start up our counts. And they go through, because they're going to overwinter as eggs, nothing's going to change. You know, we could pretty much wrap up by end of December. We compile that information, we present it to the townships. Here's your acres, here's our proposed blocks that we're proposing. You interested, yes or no? And from January on, we have multiple meetings with the townships. They have to provide all the notification to the residents of the spray blocks by newspaper and by direct mailing to all the people in there. They have to finance the total cost of the spray operation. We in turn find a vendor through contracting process, a reputable vendor to provide the services. So we get them all to meet, we get them all to sign the contract, and then we apply to the U.S. Forest Service to get some reimbursement monies that we would give half reimbursements, because that's the maximum reimbursements municipalities can get for their treatment costs, but we reimburse half their treatment costs back to the municipalities for their effort. So at first it's a heavy financial lift. You know, there's some townships that you just saw that are going to be spending about $98,000, you know, for a double application.
Yeah, I know with your egg mass counts, one of the challenges, especially with the white oak groups with their exfoliating bark, is that these egg masses are often at least partially hidden by these bark flaps.
Right.
And you know, the more white colored bark makes it a bit challenging, perhaps. And this the fact that maybe you underestimate by 25% or more. Is that a common trend?
Well, that can be right, especially looking through binoculars. It's hard to. I mean, it's nice when the coloration is there, when they all look nice and buckskin colored. You know, it's really easy to tell an old egg mass from a new one, especially with using binoculars. And in low populations, binoculars are very useful, because in low gypsum moth populations, when they're just kind of festering and you don't even know they're there, they usually lay their eggs higher up in the tree. When they get those 4,000 to 6,000 egg masses an acre category, they're laying them all over the tree, low, high, it doesn't matter. But the coloration helps you when you use binoculars to spot them, to go, is this an old one, is this a new one? And there's human error, absolutely. You know, there's a lot of training, and the more experience you have, the better you get at it. That's how it is.
Just the slide showing you, it's kind of a relative comparison with maybe a small, medium versus large egg mass. They can get up to about 1.5 inches or so. And that's when you have perhaps as much as over 1,000 eggs per mass. Right. Whereas if you have a small one, maybe less than 1/2 inch, you could perhaps only have 100 eggs in the mass. And they would often, the small ones, when you start seeing a lot of those, and you're not very particularly concerned about them, because that indicates that you've had probably a good amount of the fungus as well as the virus have established itself in that area, and it's really crashing the population.
You get that too, along with with the smaller ones, the dime sized ones. They have less eggs per egg mass, you know, like you were saying earlier. But we also see that in stressed areas. So areas that had like that way back slide in the mountains of Pennsylvania, for example, you know, there's that complete defoliation. If they're still actively feeding and they get, because of their sheer numbers, that kind of defoliation, now they're starting to get stressed, the insects themselves, right? And so they're not getting the full nutritional load that they need to develop nice, healthy egg masses. So you get that stress factor, you get smaller egg masses, right? One thing too with the egg masses is that, so some people will just scrape off the ones that they can reach. You know, you can scrape them off of the tray so that they don't hatch in May, right? End of April, beginning of May. But gypsy moth eggs are kind of unique in the fact, some insects like spider lanternfly, you could do that. You could scrape the eggs, disrupt them, and they're not going to hatch because you've destroyed them and you're scraping. Gypsy moth, They're like little BBs, right? They're these little balls. And they don't really care if they're in that egg mass cluster or not, especially this time of year. If you just scraped it, there's individual eggs or wherever they fall on the ground, they're going to hatch. When it's time to hatch,
Right.
they're going to hatch. And so we always recommend people that if you're scraping gypsy moth egg masses, to do a whatever you can do to kind of reduce the population at your house, for example, to scrape them into something. You know, and we just say, get a jar, scrape them into the jar, throw some straight bleach in it. That'll eat through that egg coating. Nothing's going to hatch out of that.
I've heard stories, Joe, that you can maybe put them in a coffee can and then put them over a fire and hear
Yes,
them
right.
pop.
And they,
Hear them
and
pop.
they will-
Wow.
That's correct.
What a joy for a young pre-teenage boy to do something like that.
That's correct. That's correct.
Yeah.
And the one thing with egg masses too, I remember back in the day, before my time, but when they first had those outbreaks of gypsy moth back in the 60s, they used to destroy egg masses, they used to paint the egg masses that they could reach with creosote. And creosote, they use them to protect, marine timber from worms. It's pretty nasty stuff. And what they found out was they painted these egg masses thinking that they destroyed them, but the eggs are laid in layers, almost like an onion, right? And so you're destroying that outer coating of eggs that the female has put out, but the ones underneath, tight against the bark, are still viable. And so they would see caterpillars coming out from these creosote covered eggs because they never killed the inner ones, they killed the outer ones, right? If that makes sense.
Yeah, I have had people ask me, what about a cold winter, with the eggs, or can they maybe be less viable? And I always tell them, at least in New Jersey, that's not going to happen because they can tolerate temperatures up to about minus 20 degrees Fahrenheit, and they can tolerate that for maybe 2 or 3 days before they start to maybe lose some of their viability. So no, we're not going to reach those cold temperatures here in this state.
Right, that kind of stuff you see in like upstate, the UP of Michigan or something, if it's an incredibly cold winter. Yeah,
that's right. So this is just showing here what we have as far as residential thresholds, right, as well as urban park thresholds, where we're trying to keep the number of egg masses. When we reach them at these numbers, that indicates that you're going to have, at least with residential thresholds, it's going to be a kind of an aesthetic problem or even a sanitary problem with all the frass and right, droppings and so forth. And with urban park thresholds, you double that. That would indicate that try to keep it under 500 egg masses. We need to do treatments. Otherwise, you'll get more than 50% defoliation.
Right.
And, yeah. And as far as BT use, I know you indicate the limitations with that. When they begin to exceed, 1,200 egg masses, and this is now per acre, it's maybe time to use, put the BT away and use some more conventional materials.
That would be great to go with a broad spectrum, especially in residential areas. If you have, with the BT used in residential areas, great. We have to use that because we're using aircraft and we're doing area-wide spraying, right? Residents, they could always hire a ground spray company. They have synthetics that they could use that give a much higher rate of kill and are more residual. So you have that option, but now you're limited by where can they get their gear to, right? So they can't treat all the trees in the woodlot. They can only get the ones that they can get their gear to. So,
trying to estimate the number of egg masses in an acre, that's really kind of a large area that's very difficult to do. And so what has been done is to simplify things. And I know Joe and his team at the New Jersey the Department of Agriculture use this 37-foot diameter circle, or 1/40th of an acre technique. Right. And you do more than just one, of course. If you have a 50-acre plot of oak trees, for example, you may want to do at least 5, 6, 7 of these representative circles.
So usually our staff will go out and we have a data sheet, a survey sheet, and usually we'll spin 3 of these, doing all the egg masses that we see, high and low, to total them up, and then we pull the average, because you're right, there's human error there. So you might get a higher count here at this place than a lower count there. And so we pull the average. That's where we come up with our base population class for that site. And then, like you said, you should go out to other places on your house or in your woodlot or whatever to see if that population is consistent or not. Because gypsy moth has a tendency, from my observations, to be higher along the wood line edge than they get to be deeper into the woods.
Yes.
And I think it has to do with airflow and movement and all that. But it's just an anecdotal observation that I've seen. I get higher counts along the road than as you start walking into the woods. They're still there, but just not as high as normal.
And this slide just shows you, with the simplification of using a 37-foot diameter, it does not take a lot of egg masses to reach threshold. You know,
Correct.
7 egg masses for a residential site in a 37-foot circle, or 13 in more of an urban park site.
Well, even looking at the 7, you know, if you had a large egg mass, if they were large, you know, you're talking, what's in there? Say 500 egg masses, so you have 3,500 caterpillars coming out. They're all going to be right. So, you know, minimum.
And when you reach 30 egg masses, just move, I think. You're going to have a severe defoliation unless you do something. Yeah. So, and there's, you know, this, I'm going to flow through this because I know we're getting close to the end of time remaining. But there's a number of non-insecticide spray management strategies. And this is typically useful for such physical controls like removal of the eggs and larvae. You know, it helps to a degree. Native predators like small mammals and birds, they can maybe be useful in a low density population area, and perhaps keep an area from getting to an outbreak type of a population. So they can play their part, but they can't be relied on to prevent an outbreak. They'll be overwhelmed. And then we do have the importation of a good number of natural enemies and pathogens. You know, the natural enemies is mostly parasitoids. And then we've got these, we brought in a fungus, as Joe mentioned before, this Entomophica maiga, that's been kind of the workhorse to help suppress them over the decades now.
Right.
And then we've already mentioned about the mating disruption pheromones, and this showing you the burlap banding technique. And, you know, I've heard that if you're persistent with this, you know, during the day, they kind of move down, and when they're maybe the younger instars, and they go underneath the protection of these burlap, where you kind of fold it at the top and halfway down, maybe 18 inches wider. So you can look along the whole row of these oaks. Every one of them has these bands. And this was apparently in Worcester, Massachusetts. This photograph was taken. But Joe, I've heard that if you do this persistently and you scrape them off before they move back up higher at night,
Right, so it's a lot of work. So people who do this, so people who do this technique, it's a lot of work. You know, you come home from work, and now you're going to pick up these burlap things, and you have to scrape the caterpillars that are under there. And then, you have to scrape them into, like, people scrape them into buckets of soapy water, for example. So you get to do that every day for a month. That's, you know.
Hey, it's fun.
It's fun, and but you're protecting your trees, and you're getting a little peace of mind. You're getting a little payback.
Yeah. Maybe it makes you feel good. So, and again, just showing you the spongy egg masses. Is to scrape them off. You know, don't, as Joe mentioned, don't just scrape them off and let them fall on the ground. They're going to hatch.
Right. And
they'll just simply crawl up the trees. And so you got from July through April to do a lot of your egg scraping. So you know it's not a practical thing to do in more of a forested area, but for a residential site, you can maybe reduce at a low level. You can prevent the density from building up to a higher level, perhaps. Right. And there's a number of you know, mammals and so forth, and a few insects that are actually native. Mice, especially apparently white-footed mice, shrews and chipmunks and squirrels and raccoons. But again, kind of emphasize, this is really only an impact if during a low density populations, and just prevents them from building up higher. And there's some spiders and ants and other insect predators. And there's some bird species as well, chickadees, blue jays, robins. And then when they really get higher levels, then you have other attractive type birds moving in, like starlings and grackles and red-winged blackbirds. And so they just come in when the populations really get high. So they help, you know, but they're not going to maybe prevent excessive defoliation of the trees during outbreak years. And so this is the importation that has been done over the last several decades. I think it was mostly concluded by the end of the 70s. Correct me if I'm wrong with that, Joe, but we have about 7 wasp parasitoids that were brought in and 3 fly parasitoids.
Correct.
And one predator. I think that would maybe be a European ground beetle.
Yeah, we do have a ground beetle predator, and all those have been established. We've stopped release. So the biocontrol world works where, because biocontrol, especially unless you're on an island, is very difficult to get because a lot of these predators will move on, right? They'll move out. They're going to follow their host. And so we go for establishment. So we rear them, we release them, we make sure that they're established, and then we move on. So these were all paid for by Forest Service funds way back when in the 70s, right? When Gypsy Moth was in its heyday. And all of these are you can find them along with the Emai Mega. You can find that anywhere within the state. There's a field card number. You will see those. You'll see signs of these things. But with any kind of beneficial, it's not the silver bullet. All you're doing is you're putting these native parasitoids out there to create a more, they kind of knock down that population, but they're not going to reduce it to nothing, right? So what they do is they work on their own. Their numbers are always lagging behind their prey. So prey in this case is Gypsy Moth. These guys are going to go out there. They're going to start at low numbers, even where Gypsy Moth hasn't been around for about 2 or 3 years. They're still there, just in very low numbers. Their numbers will slowly build up as Gypsy Moth populations build up until the point where they'll reach a critical point years down the road to make those Gypsy Moth populations collapse. So it's this sine wave that's always following the prey sine wave that kind of goes on forever and ever and ever. So we're trying to make this natural predator environment is the basis of biocontrol to kind of not eliminate the organism that you're trying to control, but kind of reduce their populations. And sometimes when the populations explode, sometimes you have to do a spray operation to help out the beneficials, keeping them.
Some of you listening may not be familiar with the term parasitoids. Essentially, they're mostly wasps and fly species. And essentially what they are, they're parasites, but they kill their host. And they can lay their eggs within the different stages of it. In this case, insects, the egg stage or the larval stage, or even more rarely the pupal stage. And they will eventually just kill the host and prevent that life cycle from continuing. But this is Oencritis cuvanae, which is brought in, I believe it was brought in from Europe, or was it Asia? I think
it was Asia.
Was it Asia? Yeah. And this is one that, you might see, as I showed you that photograph earlier on, you'll see these openings, and you think they're perhaps the exit holes of the caterpillar, but that's not correct. These are the parasitoid exit holes. Once they've done their feeding on the eggs, they'll emerge as wasps, and they leave these exit holes there within the webbing of the egg mass. They don't go very deep. Their ovipositors are relatively short, and so there's a bit of a thickness with these eggs. And so they're mostly just getting the surface. I don't know, it's probably 10% of the egg mass. I'm not sure what the percentages are.
Yeah, depending on the size of the egg mass. But right. Yeah. But it's something. It's a little less, a few hundred less for other action to be taken, right?
A lot of these things can collectively accumulate, and a lot of background predators and parasitoids, and with the fungus and viruses, that all helps to create suppression overall. And these are some of the ones that are really the workhorses with our spongy moth caterpillars over the years. And probably the top 2 would be the Entomophica, which is a fungus which was intentionally introduced from Asia, and as Joe has been talked about. And then we also had this naturally occurring viral organism, pathogens, called the nuclear polyhedrosis virus. And we can apply that as a spray as well, Gyp check. And so anyway, there's a bacterial as well, Clostridium, but that's a bit more of a minor player. Apparently the 2 workhorses are the ones shown there. And I just do have some photographs. Let me get to it here, just showing you that it's really been very effective at times when the weather conditions are right. This Entomophica maiaica fungus from Asia really works well. And this is showing you what happens to the caterpillar larvae. It's just a dry rot that occurs. In fact, when I took this photograph afterwards, I took the blade of my knife and I pressed it up against this dead carcass, and it just simply crumbled.
Right.
So it's kind of a dry rot, and so then you know, it lives in the soil and on tree bark and spreads pretty easily. And it's spread throughout, you know, as Joe mentioned, all throughout New Jersey and much of the Northeast.
Right.
And effective in many states. But they do like the cool, wet springs, this fungus, to be most virulent and most effective.
Right.
Since you know, as the years are probably more like decades go by with the you know, the climate change and maybe our springs becoming warmer and perhaps more dry, which hasn't occurred, at least not in this part of the country. But you know, it could certainly an opening up for resurgence of the spongy moth.
Right.
Yeah, it's very possible. So, all right, that's in the more distant future. And this showing you the NPV virus, late instar. And this is the one that really goes after outbreak years, when the gypsy moths, their food quality really becomes you know, reduced. There are tremendous populations, and they're running out of food, and then this virus comes in and just wipes them out. And so many of them won't be able to become adults, and they won't be laying eggs, and so that cycle is broken. And for the following year, it'll crash, and you'll have much fallout. But this is a characteristic appearance to them. They will often have an inverted V after infection, and they're often more of a shiny appearance to them. A little bit, you can see a little bit of shiny taking place here. They will hang by the middle of their prolegs. That's a common trend that occurs after an infection as well. So, all right, I don't know, Joe, we're getting pretty late here. It's quarter after. This is showing you a bacterium. Just to show you, if I put my knife up against this is what I did. It's a bacterial infection, and just a viscous ooze emerged out of this caterpillar. And this is another one of these pathogens that plays a part. And so we got a lot of sprays that we can do. You know, the older traditional sprays that we are often being slowly reduced. DDT was banned, I believe it was 1970, but that was very effective. That was very effective at suppressing the spongy moth. And then after DDT left, we kind of focused on 7 or orthene, and some of these other materials like pyrethroids are still all very effective, but they require you know, a lot of broadcast cover treatments to work.
Right, and those you'd have to hire a ground spray rig, spray company to do them, and you're limited by what trees can you get those rigs to. So you're limited in scope, I guess.
But these are some of the more reduced risk insecticides that have become available, and there's new ones that occasionally still come out. Soaps, it probably just works really well against the earlier instars. You know, these caterpillars are very hairy, and that soap has to have good contact, and it maybe gets caught up in the hairs, and maybe it'd be less effective as the caterpillar ages. But BT is certainly one of the primary reduced risk materials we've been using through the years. And Dimilin, I don't know if the time we have left, perhaps this could be the final story, Joe, you want to tell about, you know, what your Department of Ag dealt with during that year of 07 through 09. You were concerned about Bacillus thuringiensis having resistance, and you're thinking about, so go ahead and tell that story.
So with any insect control, and when you're doing it year after year after year, insects will develop resistance. And there's always been talk of BT resistance. And it goes back to the diamond moth. In the agricultural world, they use BT a lot. And diamond moth was showing resistance because that's all that was used on these particular crops in these ag fields. And so that kind of raised the concern on that. So they developed IGRs. And IGRs are great, like Dimilin, and I think it was confirmed underneath that. I can't remember, but they're also good, and they also must be ingested by the organism, by the caterpillar. It has to be fed. It's not a contact poison. Like 7's a contact poison, and it's residual. So if it hits the caterpillar, it's going to kill it. Or if it eats material that has it, it's going to kill it. BTs have to be eaten. IGRs have to be eaten, but they have problems with decreasing populations in aquatic environments. So you have to keep the IGRs out of waterways, out of streams, out of ponds, that kind of stuff. You're decrease those little aquatic organisms. So IGRs work very well, and they're very cheap because they're synthetic. However, we try to apply those by air. We need a permit to do that, and a waiver, and it's easier said than done. And so we weren't allowed to do that, but nothing stops homeowners from hiring ground spray companies to use IGRs that they're more residual, they're more effective against the larger caterpillars than BTs are. And you get a much better control because they're more residual. BT, like I was telling you earlier, last a week, you're going to get about a good 65% knockdown, but you're still going to have caterpillars there at the end of the day. You know, hence we have those areas with the double lab. The IGRs, one application, you can put it out there, it's there, it lasts for, maybe a month. It's a lot cheaper to use, gives you a lot better kill because it's residual, but you have water issues that you have to deal with. So you have to keep it out of your ponds, your streams, that kind of stuff. That's so in a nutshell, that's how it is. Sometimes some of these get political for me to use, but nothing stops homeowners from hiring a ground spray company, a licensed applicators, to apply the material properly and get a better job around your house.
Yeah, we were talking about this, Joe and I, before the program began, and it was a real concern as far as the resistance occurring with BT. And as you mentioned, the insect growth regulator is what is the active ingredient, and it's Dimilin is, I think, what was being promoted, but you guys were shot down. The Department of Environmental Protection didn't allow you to do it, and the reason is that this insect growth regulator is it's a chitin synthesis inhibitor, and it prevents the proper molting of insects or also aquatic crustaceans, things like crabs and clams and I guess lobsters as well.
And even plankton in freshwater environments.
Yeah, is that right? Okay. Yeah. So anyway, fortunately that outbreak subsided after starting in 2010, and it wasn't really the concern anymore after that, right?
Right.
So okay, all right. Well, we kind of talked about all of it. This is that window that's so critical with BT. That probably the second instar would be the focus area to try to hit, and then when you get to the third instar, in fact, when the caterpillars get much more than an inch, that probably means that they're perhaps fourth instar, and then you don't really want to. And it's still obviously anything like this is the eastern tank caterpillar with that white racing stripe down the back. So you can never confuse this with a gypsy moth. They're very easy to tell apart. But this would be certainly a late stage caterpillar. BT, like Joe mentioned, would not work. And this is just research out of University of Maryland showing you percent mortality with the gypsy moth at different instars, BT second instar, BT third instar. So it definitely reduced, and this is just a single study here, but it's been replicated. BT third instar, you still get maybe 75% mortality. But if you did a BT treatment at fifth instar, I don't know what you would have. Probably
you wouldn't have anything.
Nothing probably. And so that's when you go with the more conventional materials. They just happen to choose Tempo, which is a pyrethroid, and you got right back up there to 95%. So, so just to be aware of that. And so that's it. And we actually got through it. It's getting late. Hopefully some of you guys are hanging in there. And so, Joe, I'll move in, and I know you need to have any kind of this time for questions. I don't know if there are, but Joe, I'll let you kind of take over here.
All right. Thank you very much, Steve and Joe. That was a fantastic, really fascinating presentation. It shows that there's hope. There's natural things. A wet spring, provides a natural resistance to the gypsy moths. And then in bad cases, there's things we can do to make the situation better. So I appreciate that. And thank you for your time to give us a presentation. There are a few people watching live, so we'll hang on a little bit and see if anybody calls in with their questions.
Okay.
Sure.
Yeah.
But definitely a lot of those places that we looked at and the maps are in the Pine Barrens. And, over the years, there's definitely been an effect, particularly on the oak trees. Not too long ago, I think last spring, I was down in Brendan State Forest and I saw substantial egg masses and moths were still active. So it can be a problem, and between our methods and between nature, hopefully it keeps it in check.
Yeah, yeah, Joel, when you invited me with Joe to give this talk, I was a little bit surprised because for me, the gypsy moth was really kind of fallen off the radar. And I don't typically talk about it anymore. And certainly back in my earlier years at Rutgers, I did much more consistently. And then during that resurgence again in 07, 08, 09, I also talked a few times about it. So it's been over well over a dozen years since I've given a presentation on this particular insect. So I had to dust off some old slides that I had, and so anyway.
Some of the challenges we get is that, so we do if we do a great job of spraying and gypsy moth populations collapse like they historically do, without some minor outbreaks hither and yon, so then we have new administrations coming in, and so we have new people that we go, wow, you have a problem. They have no clue what we're even talking about, and so we have to re-educate them as to the necessity of doing a timely treatment. Otherwise, it's just going to get worse, and we're doing a spread. It's going to get worse and worse and worse. You're going to spend more money next year than you would if you just did it this year, kind of thing. So we're always educating new administrators. The old timers are retired. They're the ones who know about gypsy moth, and so that's what we constantly do.
Probably the most interesting part about this whole, getting prepared for the talk was the fact of this name change that took place. That's really quite something. And I was talking to Joe earlier before the program again that there's going to be people who are going to, it's a time of a sign of our times, I guess, where this is going to be taking place. And I guess it's appropriate. I'm sure it is appropriate. And so therefore, it's just going to take amount of time for this name change to sink in, and probably within 10 years, nothing will be thought of it. Although I tell you, I will still struggle whenever someone talks about it, not to call it the gypsy moth, but that's
correct.
Yeah.
And they have a problem with, so I still call it LDD, which is a scientific name. Steve, you had it posted up, Lomantria dispar, so it's a genus, species, subspecies. So the European versions, easy, just call it LDD. That's what I do.
Yes.
But the Asian variety, I have to bite my tongue. The Asian variety is not so easy. So they still call it AGM, is what they call it. But they, because there's 5 subspecies, so it gets into, and you can't even make an acronym out of it. The federal government likes to use acronyms all over the place. And they're even struggling with trying to make an acronym out of all the subspecies for AGM. So they still call it AGM now, but they're working on it to change that.
All right. Well, again, I want to thank you. I don't think anybody's going to call in today, but that's okay. That's just a sign that you did a great job. And
Joel, everyone's worried about the spotted lanternfly. That's why.
Yeah, spotted lanternfly. Well, it's kind of quiet now, but they're going to be hatching out. They hatch out around May. So at the same time as gypsy moth spray operations are going on. And they're nymphs, and people don't even notice the nymphs because they're so small. It's like the size of an engorged tick, right? And then come July, when they have the color change and they're 3/4 inches larger, people do see the red nymphs, and then they turn into adults. So pretty much our phones go off the hook July on until the adults die off and all that's left of the egg masses. But like gypsy moth, they lay their eggs wherever they want to. There's no particular place that they favor. It used to be flat places. They'll lay them anywhere they want. And they're even, gypsy moth egg masses are easier to spot than spotted lanternfly egg masses because they use a hairy coating, but the females will cover them with like a gray waxy coating. And sometimes that kind of gets into the tan world. So you could look at a rock and not see one, and it's right in front of your face, just because it blends so well. It's amazing. So they're a little tougher. And they're more mobile too. They fly, so they're like, they're good hitchhikers, so they get moved faster as well.
All right. Well, thanks again. On that note, I think I'll shut down the live broadcast. And again, thanks for the information. That's
Sure.
our job, is to teach and educate. And we did a great, great efforts in those, great strides with those efforts today. So thank you both.
Yeah. Well, thanks for the invitation, Joel. And Joe, I'm glad I had an opportunity to meet you and to work with you a bit. So that was
Absolutely, same here. Yeah, you do a good job. Keep up the good work, both of you.
Right.
You're both
Oh,
doing great.
yeah.
So thank
Right.
you.
Sure enough.